Hi guys, today we'll discuss this number theory problem from Waterloo's grade 11 Fermat contest. This is question number 21 from year 2006, and it reads that for how many integers n with n between 2 and 80 inclusive is n minus 1 times n plus 1 divided by 8 equal to an integer. Now this is a classic divisibility problem because you're asking the result of a division to be integer, right? And we know that one of the most helpful tools you can have for analyzing divisibility problems is prime factorization. So let's take a look at this expression. You have n minus 1 times n plus 1, right? And these are three consecutive integers. You're dividing them by 8. And if you were to prime factorize 8, it is really 2 to the power of 3. Right? You divide by 2 3 times. That's my interpretation of it. So take a look at this, right? We know that an odd number can never be divided by any power of 2, right? Whereas an even number, right, they will always be divisible by 2 one time. And sometimes it can be divided by 4, sometimes by 8, right? So that depends. So I think it is combined with the fact that you're dealing with 3 consecutive integers, it makes sense to break this problem down into 2 separate cases, right? In the first case, n is odd, which means the 2 numbers around it must be even. In the second case, n is even, then the 2 numbers around it must be odd. Right? So let's now dive into them in details. Let's first consider the case when n is even, which means that the 2 numbers around it, n minus 1, n plus 1, must be odd. And there's no way these 2 odd numbers could be divisible by 8. Therefore, n itself must be divisible by 8. So let's think about all the numbers, right, within the range of n that could be divisible by 8. You have 8, 16, 24, and so on, all the way until 80, right? So therefore, you have 10 choices when n is even. Now let's consider a case when n is odd, and we know that we can write any odd number in the form of 2k plus 1, where k is any integer, right? And the reason is 2k will always be an even number, and if you plus 1 to it, then the result is going to be an odd number. And accordingly, we'll set k to be between 1 and 39, such that n will be between 2 and 80. Now, using this expression of n, we can write n minus 1 as 2k plus 1 minus 1, which is 2k, and this is an even number. We can write n plus 1 as 2k plus 1 plus 1, and which is equal to 2 times bracket k plus 1, and we know that this number is also an even number. Therefore, the expression given by the question, n minus 1 times n plus 1 over 8, we can really rewrite that as 2k times 2k plus 1 times 2 times k plus 1 divided by 2 to the power of 3. And if you want, you can cancel out the 2 2's on the top, right? You're left with k, 2k plus 1, k plus 1 divided by 2. And we know that 2k plus 1 is an odd number, therefore it can never be divisible by 2. So therefore, you just need to find a k such that k times k plus 1 is divisible by 2. Right? So k and k plus 1, if you pay attention, these are 2 consecutive integers, right? And we know that if 2 integers are consecutive, one of them must be even, and the other must be odd. So for example, if k is odd, then k plus 1 must be even. Or if k is even, then k plus 1 must be odd. So we know that at least one of k and k plus 1 will always be even. Therefore, k times k plus 1 will always be divisible by 2. Therefore, k can take on any value between 1 and 39, because that's the restriction on k in the beginning. Therefore, based on this value of k, we can calculate the n accordingly. Just sub in 1 to 39, sub 1 to 39 into k. We can just do 2k plus 1. You can get your n. All right, so let's put things together. So when n is even, we know that n must be 8, 16, 24, so on until 80, which there are 10 choices. If n is odd, and we write n as 2k plus 1, we said that k can be any integer between 1 and 39, right? And for each of the 39 choices, you can write you can calculate your value of n. So therefore, there are 39 choices when n is odd. And if you combine them together, there are 49 choices for n.